Hi, this lesson is about the characteristics of quadratic functions and graphing them. So quadratic functions are functions that are considered to be a polynomial function, but where the highest exponent of the independent variable is 2. What that means is that quadratic functions have a degree of 2. So this is the most common form that you've probably already seen quadratic functions expressed as ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is your constant. So you can have a quadratic function without the b term and without the c term, but you do need that x squared term in order for it to be considered a quadratic. Another less common way to see your quadratic function is in this form. So f of x equal to a times x minus h squared plus k. And it's really handy to see it in this form because you can pick out your vertex from here. So the x coordinate would be the opposite sign of whatever's associated with the x, and the k would be the constant that's being added after. So you can think of this in terms of shifting. So this would be a horizontal shift h units right, and this would be a vertical shift k units up from 0, 0, because remember the vertex of x squared is just 0, 0. So the way we put a quadratic function in this second form, or this form here, is by using the completing the square, that method. So here's an example of how you would do that. So we want to put this function, which is in what we would consider to be standard form, into this other form that will allow us to pick up the vertex easily. So the first thing you need to do is that you're going to be completing the square on the x part of the equation. And what that means is that you have to take half of the coefficient of x, which gives me 3, and then you take that 3 and you square it. The last time you may have used completing the square, you used it to solve an equation. That's not what we're doing here. We're actually just rewriting it in a different way. So all of your work will be on the right side of the function. So that's what you see here. That expression 3 squared is going to get added and subtracted from that right side of the equation. Because when you add and subtract the same number, the net result is just 0. So this original equation equals the second line, even though it looks a little different with that addition and subtraction of 3 squared. So now this is something that is considered a perfect square trinomial, which is factorable. And that's exactly what you see on the next line. When you factor x squared plus 6x plus, and 3 squared is just 9, you get x plus 3 times x plus 3, which is x plus 3 squared. And when you combine these two, minus 7 minus 9, you get the negative 16. So your vertex is negative 3. Remember, you take the opposite sign here. And then the y value is exactly what you see as your constant after you've squared the x value. So that's just negative 16. Okay, so let's do another one. This one's a little bit more complex because I have this leading coefficient here, and so that's something that we're going to have to keep track of. First, I'm going to factor out a negative 2 from these two terms, from the x terms. And when I do, you're left with this as your function. All right, so now I need to complete the square on this portion of it. So you take half of 4, which is 2, and then you square it. And then that has to get added to this part of it. Okay, but notice that here I didn't subtract 2 squared the way I did in the last example, because this actually isn't 2 squared. If you were to distribute this, negative 2, across, negative 2 times 2 squared is a minus 8. And so remember, the net result of what you add or subtract to this line has to be 0. So since this distribution is negative 8, that means I have to add 8 in order for it to work out to just be 0. So that leaves me with the next line, which is factor the x squared plus 4x plus 2 squared, which is 4, and that gives me x plus 2 squared. The negative 2 is on the outside, that's fine, and then 1 plus 8 gives me 9. All right, so what I know is that my vertex is the opposite sign of this number, which is negative 2, and then that number is your y-coordinate, which is 9. We also know that this will be a downward-facing parabola because my leading coefficient is negative. Okay, let's look at another way to find the vertex of a parabola. And this other way is by using a formula. So you may have learned this in previous math classes. So first, let me just state here and put it in writing what I mentioned a minute ago. When you're graphing a quadratic equation, the graph is called a parabola. It will have a U shape, and when the leading coefficient is negative, the parabola will face downward. It will be an upside down U. When the leading coefficient is positive, it will face upward. So if you have an equation in this form, a quadratic equation in this form, we can find the vertex by using a formula. And the formula is right here. Your x-coordinate is found by plugging into the formula negative b over 2a, and the b and a come from whatever these coefficients are. And then the y-coordinate comes from plugging in whatever you get for the x value into the function itself, and then calculating what the y value is. And you get the same results as if you had done it with the first method we did in the previous examples. And just to remind you of something we talked about in a previous section, if your a is negative, meaning the parabola is going to be an upside down U, then your vertex is going to be a global and a relative maximum point. Remember that another word there would be universal, and here another word would be local maximum. And that's because it would be an upside down U, so the vertex would be the highest value overall. So that's why it would be considered a maximum. And if your A is positive, meaning it's an upward facing U, something like this, then your vertex is going to be a global and a relative minimum. So there will be nothing smaller than that vertex value on your graph. Okay, so let's find the vertex by using this formula. So here the question is identifying the maximum point as well as the domain in the range of negative x squared plus 2x minus 5. So this is a downward facing parabola. That's how I know it's going to be a maximum. Your vertex will be a maximum. So you're basically being asked to find the vertex. So we're going to use this formula above, that one here. So I have negative b over 2a. Your b is 2, so that will be negative 2 over 2 times, and your a is negative 1, so 2 times negative 1. When you simplify that, you get that x is 1. Then to find your y value, you plug in 1 in here, which is the work you see right here. So I have negative, and then it's 1 squared plus 2 times 1 minus 5. That'll give you negative 4 as a result. So 1, negative 4 is the maximum point. Since it is a maximum point, you know that it's, I'll just sketch it really quick. So 1, negative 4, that means you go 1 to the right and 4 down, so you're here. So your graph would look something like this, okay? So Your domain is always all real numbers when you're talking about quadratics, but your range is all real numbers from negative infinity all the way up to -4, and that's it. There's nothing above -4. So remember, read your y values when you're identifying range. All right, let's get a few more attributes for parabolas intercepts. So we have an x-intercept when the graph crosses the x-axis, and that's when y is equal to 0. And we have a y-intercept where the graph crosses the y-axis, which is when x is equal to 0. So y-intercepts are easy to find. X-intercepts require for you to use some sort of technique, factoring if it's factorable, or quadratic formula is another option. So we want to find the vertex, the x and y intercepts, and then sketch the graph for this function here, x squared plus 4x minus 5. So I'm going to use the first method to find the vertex. You can use any method you want. So since I'm using the first method, I decided to complete the square. So I'm going to take half of the coefficient of x, which is 4. Half of 4 is 2, and then we square it, and when we square it, it has a value of 4. So I'm going to add 4 and subtract 4 from the right side of the equation. So the x squared plus 4x plus 4, so this expression here, that's your perfect square trinomial. That factors into x plus 2 to the second power. And -5 minus 4 gives me a value of -9. So that means I have a vertex at -2, -9. Okay, so now I have to find my intercepts. I'm going to start with the y-intercept because, as I mentioned, it's just the easiest one to find. Y-intercept is when x is equal to 0. So if you plug in 0 in for x, you're just going to get a y value of -5. So 0, -5 is a point on the curve. Then we have to find our x-intercepts, and we find x-intercepts by letting y equal 0. So we're going to take our original equation and set it equal to y. So that one happens to be factorable, which is the quickest way to solve it. So the factors are x plus 5 and x minus 1, which gives us two solutions, -5 and +1. So as coordinates, you would state that as -5, 0, and 1, 0. All right, so all of these points, the vertex and the intercepts, have to be plotted. So here's my vertex. You go 2 to the left and 9 down. Here's my y-intercept, 0, -5, just means you go down 5 units. And the two x-intercepts, the first one is -5, 0, so that means you go 5 units left. The second one is 1, 0, so that means you go 1 unit to the right. So you graph from left to right, so the leftmost point is the x-intercept -5, 0, and then connect them sequentially from left to right, and so you get this U shape that you see here on the left. Okay, so suppose you have a quadratic equation that is not factorable, like this last example. When that's the case, a quick way that it doesn't give too much trouble to solve the equation is to use the quadratic formula. And so the quadratic formula is here. This is an important formula to know and memorize for this class as well as future math classes. So it is -b plus or minus the square root of b squared minus 4ac, and that entire numerator is over 2a, and that a, b, and c come from here. As long as it's in standard form, you can pick out your a, b, and c, and then just plug it in. So here's an example. We want to identify the maximum height, the t-intercepts, and the y-intercept for this function, which is h of t equal to -t squared minus 2t plus 6. So the maximum height will basically be the y value of the vertex because I know it's an upside down parabola, so there will be a maximum there. So let's find the vertex. So I'm going to use the second method, which is to use negative b over 2a. So my a is -1, my b is -2, and my c is 6. Okay, so t, as we're calling it t instead of x, is negative b, which is -2, over 2 times a, which is 2 times -1. So that works out to be a -1 because you have a positive in the numerator and a negative in the denominator. So you get -1 as the t coordinate, or the independent variable of the vertex. So now I have to find the y value, and the y value is h of t. So we have h of -1 will give me -1 squared minus 2 times -1 plus 6, and that simplifies down to 7. So I have a vertex of -1, +7, which means that the maximum height of this parabola will be 7, right? The height is the y value. All right, so now let's find our intercepts. So I'm going to find the t-intercepts first. So even if you tried, this one is not factorable. So I'm going to plug it into the quadratic formula, which is what you see above. So I have negative b, which is -2, plus or minus -2 squared, minus 4 times -1 times 6. So we need to simplify what's inside the square root first. So that is 4 plus 24, and also 2 negatives make a positive 2 here. And the denominator is just -2. All right, so we have to add the 4 and the 24, so that gives me root 28. But 28 can be rewritten as 4 times 7. So the square root of 4 is 2. That comes out, and the 7 stays on the inside. So I'm left with 2 plus or minus 2 root 7 over -2. But both of these 2's are divisible by -2. So that gives me -1 plus or minus root 7. Since I want to graph these, you're going to want to know what these are, like, approximately. So with a calculator, -1 minus root 7 would give me the -3.6, and -1 plus root 7 would give me the positive 1.6. So these are rounded values. That's why you see this curly equal sign. That means approximately equal to. And that's just for graphing purposes, so that we know where to go on the graph. To find the y-intercept, that's the work you see here. You let t equal 0, and when you let t equal 0, you get a y-intercept of 0, 6. All right, so all of these points are now plotted here on the right. So here's my vertex, -1, 7. Here's my y-intercept, 0, 6. And then my two t-intercepts, because remember this is t here instead of x, is at -3.6. So that's like between -3 and -4, closer to -4. And the other one is at 1.6, which is between 1 and 2, closer to 2. Okay, so that's it for this lesson. Give the homework a try. Good luck.